And we want to look at slightly longer stoichiometric problems where we start with a mass of one substance and we do the stoichiometric math all the way to the mass of the second substance. So let's take a look here through our process and figure out what we're supposed to do. So I see the word, what mass of CO2 is produced. So remember, the right-hand side of the diagram is always where we're going to end. And this time mathematically, we are ending in the quantity of mass, and it belongs to CO2. So when I go up and I look at the reaction, I know that to solve this problem, I need to know something about CO2 from this problem. And then as I keep on reading, okay, I see a quantity, 194.5 Gs. I understand that's a mass. Well, just using like a little bit of thought process, I realized, well, if I'm ending in this mass, here is the only other spot that also represents mass. And I noticed that this one belongs to O2. This is a different substance than CO2. So I'm starting on the left. So we always start on the left, and we start with mass information that belongs to O2. So that means in this problem, I also am going to need some information about O2. So as I'm looking at my roadmap, the mole diagram, I'm starting in the mass of the O2, and I've got to get all the way over to the mass of the CO2. So that the only thing that I can change mass of O2 into is to change it to moles of O2. So that would be step one. In order to get to CO2, then that means that I need to then cross from moles of O2, and I need to get to this other box of moles. But once when I cross over to the other side, it's no longer O2, then I can calculate the number of moles of CO2. Once when I know moles of CO2, now I can continue the roadmap to my final destination of mass of CO2. So let's just get our math set up, and then we'll think about final information. So I know I'm starting with, I have 194.5 grams of O2. Based on my roadmap, okay, I know that I want to move from grams of O2, and I want to get to moles of O2. So there's my setup. G's of O2 will cancel. Upstairs, downstairs. Right now I'm standing in moles of O2. Once when I've got myself set up for knowing moles of O2, I'm going to continue my math on. I'm just going to work with units until I get to my end spot. I want to leave behind moles of O2, and I want to end up now in my second step, moles of CO2. So with this equivalence in place, I have gone from moles of O2, now I'm in the shape for moles of CO2. From the moles of CO2, I want to change and continue on to mass of O2. So in this next step, I want to eliminate moles of CO2, and I want to get 2 grams of CO2. And ultimately end in the number of grams of CO2 from this reaction. So taking a look here. Okay, so to go from mass of O2 to moles of O2, same substance, different quantity, it requires GFM. So remember, 1 mole of O2 is represented by the GFM of O2. So the GFM of O2, I have 2 oxygens. Each one contributes a mass of 16. So the GFM of oxygen gas is 32.0 grams. So 1 mole of oxygen has a mass of 32.0 grams. That's what I need to put in my first equivalence. So 1 mole oxygen gas equates to 44.0 grams of oxygen gas. Moving from, now I'm looking here, moles of oxygen to moles of carbon dioxide. Well, what relates moles of oxygen to moles of carbon dioxide? The balanced reaction. So I need to know my balanced reaction, the coefficients. Well, when I go up and take a look, the reaction is not yet balanced. But if I look at my table I will find this reaction on table I fully balanced for me. So I just need to look it up. And when I look it up, table I tells me the coefficient in front of the organic is 1. The coefficient in front of oxygen is 3. In front of water, it is also 3. And in front of CO2, the coefficient is 2. So now that it's a fully balanced reaction, I just need to focus on the two coefficients of interest, oxygens and carbon dioxides. So my top one says moles of carbon dioxide. The coefficient is 2. And the bottom part is for moles of oxygen. The coefficient is 3. So I've taken care of that. Now that I have that information, now I can focus on, okay, what information do I need to have in here to go from moles of CO2 to mass of CO2? Well, moles of CO2 to mass of CO2 requires GFM information. So real quick, 1 mole of CO2 will equal the GFM of CO2. So I'll figure it out quick. 1 carbon contributes a mass of 12 plus 2 oxygens each contribute a mass of 16. So the GFM is 44.0. 1 mole of carbon dioxide equates to 44.0 grams of carbon dioxide. That's what I need to put down in here. So the top one is grams, so I put in my 44.0, and the bottom one is moles, so I put in a 1. Now that I have my information, I can pick up my calculator. And when I put this in the calculator, okay, so the calculator answer is 178.29166 and a few more digits. Well, we never write down all the digits from the calculator. So I go back and I take a look at my starting quantity, 194.5. It has 4 sig figs. So left to right, I'm going to keep 4 sig figs from the calculator answer. And the next digit, the 5th digit to the right, makes the 4th one round up. So I would record this mass, or the best final answer would be 178.3 grams.